We're joined today by Mark Cooksey, CEO of private company Alcore. Mark, thanks for your time.
Oh, you're welcome.
So firstly, Alcore, can you explain its relationship to ABX Group?
Yeah, sure. So ABX started some years ago with identifying and securing a number of bauxite deposits in the eastern states. There's various types of bauxite. There's metallurgical grade and refractory grade. And it was identified that it would be valuable to upgrade that bauxite to higher value material. It was identified that actually there was a strategic issue in Australia where aluminium fluoride, which is essential for aluminium smelting, and Australia has no local production of this material, and so we import all of it. And so the initial trigger was, well, can we upgrade our bauxite to aluminium fluoride using some technology that had been developed elsewhere or piloted elsewhere for the removal of impurities from coal. And so the opportunity was to put that all together, use that technology and to convert bauxite into aluminium fluoride, a much higher value material.
So essentially the technology was identified as a way to value add the existing bauxite assets of ABX Group at the time.
Yeah, exactly.
Since then, the technology's advanced even further, not necessarily completely away from, but in addition to its original technology, or it's an additional output and use, has now evolved to something even more valuable.
Yeah, so I guess the value of using bauxite to produce aluminium fluoride is that current aluminium fluoride is produced using aluminium hydroxide, which is a relatively high value material, and so using bauxite is much cheaper. To make aluminium fluoride, you need aluminium from the bauxite, but you also need fluorine. And so what Alcore has more recently done, so over the last 2 years, is to look at cheaper sources of fluorine than using raw material mined from the ground. And so we've identified that there's a waste from aluminium smelting, which is high in fluorine, and so we've developed a method of recovering that fluorine and putting that together with the aluminium to produce aluminium fluoride. And the cost advantage of the fluorine is actually even higher than using the aluminium from bauxite.
And so the fluorine source that you've identified is actually what could be termed from the aluminium smelters themselves as waste?
Yeah, it's an interesting material. It's called bath, and a typical modern smelter in Australia and elsewhere produces a certain amount of excess bath. For a long time, for most of the history of the aluminium industry, that was used to start up new smelters. New smelters needed a significant supply to get going. But because of the total supply-demand balance in the world right now, China's built a lot of smelters that are producing bath, and there's now not as many new smelters being produced. There's a surplus of bath, so having a waste. It hasn't traditionally been a waste problem because there's been an outlet for it, but it is quite suddenly, in terms of a major industry, becoming potentially a significant waste issue.
So not only is it a cheap source of fluorine, it actually solves a problem for aluminium producers.
Yeah, exactly. So really the industry says that the only really good outlet for that material at the moment is new smelters. And if new smelters aren't being built, there's no real good destination for it. And so smelters are confronted with difficult choices about what to do with it. So Apple coming along at the right time says, well, we can use that material, and it's a win for all parties.
So looking at the cost advantages and the output advantages, what is the technology, economically, why is the technology so important for not just ABX Group and Alcore, but for the aluminium producers themselves?
Yeah, well, the aluminium fluoride, its price is 75% of it is the raw materials. And so right now, both the aluminium and the fluorine come from mined ore. And so if we can get those from lower cost sources like bauxite or waste, such as the bath, we can make a big dent in the operating cost. I guess strategically for Australia, the even potentially bigger value is that we can produce it here. So right now, to produce aluminium fluoride, you really need a good source of fluorspar, which is the source of fluorine, and Australia actually doesn't have a lot of that. So therefore we don't produce any aluminium fluoride, therefore our smelters are at the mercy of imports. So the fact that we can now do it from these waste materials, we can do it in Australia at lower cost and give much more supply certainty to the Australian smelters. So it's a great win all around.
So you've got a technology advantage and now an economic advantage. How closely are smelters watching what Alcore's doing?
Yeah, pretty closely. So fortunately, I have a background in the aluminium industry, and so I know the key companies and key people, and I'm talking to them regularly. So they're very interested in what we're doing and hoping that we can get to commercialization as fast as possible. They see it as for the reasons just outlined, a win for them, both in being able to get cheaper aluminium fluoride and consume their excess bath. So yeah, we're in close discussions with the aluminium companies.
So technology needs to obviously go through a number of stages of validation and technical work to make sure that it can meet its commercial goals. How advanced is the technology and what are the stages you're moving into now?
Yeah, so simplistically, we'd say normally there's a laboratory stage, pilot stage, possibly a demonstration stage, and then a commercial stage. And we've demonstrated the key requirements at the laboratory stage. So we're now moving into pilot plant. So we've started constructing elements of pilot plant. It's still a bit of an iterative process, so we're continuing laboratory work at the same time to optimize the process. But the plan is to pilot the key parts of the process, in the first quarter and first half of next year. And that'll put us in a really good position to say, yes, this process works well. I mean, we already know it works. What we need to show that it works well, with high yield and efficiency. And then we can start really thinking about designing the commercial plant.
And from an ABX shareholder point of view, the evolution of this technology is clearly adding value to the company and therefore the shareholders will benefit. Absolutely.
So, I mean, the Alcore technology stands on its own 2 feet, but as ABX is the majority owner of Alcore, absolutely, our ABX shareholders are going to benefit significantly from the success of Alcore.
As we said, originally this was the original technology, I should say, was designed to extract out of bauxite. So bauxite was the key product that you really needed to drive the technology, and it's since evolved. Can the two run independently of each other? And do you need bauxite now to actually deliver the economic and operational goals that you're chasing?
They're independent, but complementary. So what the most important element is the fluorine. It's the more expensive element. And so Alcore needs to get that, or it is getting that from the smelter waste, the bath. The aluminium, there's some more options. So the conservative option is to use the current material which is used, aluminium hydroxide, and that's still an attractive for Alcore. Obviously, it doesn't use bauxite. Then there's the option of using bauxite itself, and then there's also another source of aluminium, which is another waste from the aluminium smelting industry called dross. And so they can be done independently. The choice of which source for fluorine and which source of aluminium are independent, but clearly there's a benefit, most attractive solution of using low-cost sources for both.
Clearly, access to Bath is key to delivering on the technical and operational outcomes you're trying to achieve. How have you found access to Bath? Are you finding refiners and producers are giving you the access you need?
Oh yeah, definitely. I mean, if anything, they're pushing it onto us. They're saying, can you take a look at our material and see if you can process it? So we're in close discussions with the aluminium companies. So they're supplying bath materials, for example, and then also collaborating with us in reviewing the results. So if our aluminium fluoride that we produce from the bath is slightly different to what they use now, we're discussing those results, and they're doing the work within their smelters to say, okay, how would we adapt our process slightly, not much, to slightly, in order to take advantage of the fact that this aluminium fluoride is coming from waste materials and is lower cost.
And Bath, it should be said, is a common output. There's not varying types of bath, the output that comes through is largely the same regardless of which smelter it comes from?
It's pretty consistent. I mean, it does vary slightly between smelters, but interestingly enough, because there's so much effort by the aluminium smelters over decades to optimize the process, they've all sort of converged on something of a pretty similar composition. So bath is actually a much more consistent material than ore would be out of the ground. It's quite ironic. Normally you think of a waste as being quite messy and variable and difficult to process. Actually, this material, sort of fortunately in some ways, is a very consistent material.
So Mark, you've been a process engineer for plus 20 years for some of the biggest brands and organisations globally. You've seen it all. Why does this stack up so well, and why does this excite you so much?
Yeah, I mean, I worked for Rio Tinto and then CSIRO for a long time and was involved in leading the development of a lot of new processes. And there's actually a lot of factors that need to come together to get a new process commercialised. It obviously needs to technically work, but it needs to be commercially attractive. It needs to, ideally be environmentally better. And there has to be something compelling to get a company to take a risk on a new thing. And most processes suffer from, at least one of those being a critical issue that that stops it getting commercialized. This Alcore aluminium fluoride has none, right? There's a strong strategic driver, which don't produce any here. We've got a good idea to lower the costs. We've shown that it works at a laboratory scale. We're using wastes, so it's environmentally better. And there's no competition. We're the first mover. And also there's unlikely to be much competition because of fluorine. You need to know what you're doing to do it properly, and we're one of the few that can do it. So all those factors stack up to go, this has the highest chance of success of anything I've been involved in. So it's a really exciting opportunity to make it happen.
So the path from here, what does the next sort of 6 to 12 months look like?
Yeah, well, the real focus is on piloting. So in the next 6 months. So as I said, we've started construction of the pilot plant. That will be, the key bits will be done by the end of the first quarter. And so by the end of the second quarter, we're really saying we're expecting good pilot plant results showing, yes, this process works and works well. And the information from that piloting will be then helping us design the full-scale plant, possibly with a demonstration scale plant as well. But we'll have a pretty good idea what the full-scale plant will look like early in the third quarter of this year.
An exciting piece of technology being delivered in a very strategic way, and for Australia, very strategic for our refinery industry, fixing a problem that refineries are going to see a growing issue with, high economic value and high operational value, a clear path ahead. Exciting times for Alcore and exciting times for ABX Group shareholders. Mark, thanks for your time.
Oh, thank you. Pleasure.